right, so we are going to talk about even, odd, and cofunction identities today. So we're just adding like a couple identities, but the problems are real similar. So we've already kind of talked about even, odd functions. I know my two even functions are cosine and secant. So if you have a negative inside your cosine function, it is the same thing as cosine x. Same thing for secant. Whereas the other four, if you have a negative inside the function, we can pull that negative out and it's just the negative version of the function. And so those are technically identities. They're the even, odd identities. All right, so look at, we're going to actually do 22 first. It fell off. Dang it! Hold on, I have my other one though.
Is it right?
Right where? Ooh, I think it is. Good eyes, nuts.
This is gonna be a really weird video.
Okay, we're still good. All right, so if sine theta equals 1/2, what is sine negative theta? So I know, because of the even, odd identities, that sine negative theta is the same thing as negative sine theta. And because of what was given, I know that sine theta is what? 1/2. So we can say that sine negative theta is going to be negative 1/2. All right, so let's look at 21. 21's a little bit more complicated because it's a simplifying, and I messed it up. Oh. Change that to be cosecant x, tangent over cosecant x. All right, so you can see the even, odd trig identities kind of incorporated in a simplifying problem. So this one here, I have cosine negative x plus tangent over cosecant x, and I'm going to take care of this guy first. I know that cosine of negative x is the same thing as what?
Cosine of x.
Cosine of x.
And then we gotta do the KFC.
Yeah, and then we're going to do all that stuff that we did yesterday. So I'm going to change tangent to be sine over cosine. And I'm going to change cosecant to be 1 over sine. And so this fraction right here, I need to keep, change, flip. The cosine x from the beginning, that's just going to hang out here in the beginning still. So I'm going to keep sine x over cosine times, and then flip this around. All right, so a couple things that I've noticed. You cannot, this is wrong, don't write this. You cannot do this. Those don't cancel because we are adding. All right, you only can cancel stuff if you're multiplying. So those cosines don't cancel. The other thing is, because of order of operations, generally we want to multiply first. So we're going to kind of simplify the stuff that's being multiplied first before I try to mess with the plus cosine. So this cosine x plus is going to stay cosine x plus, and then sine times sine is going to be sine squared over cosine. All right, so when you're multiplying, you can multiply across. So sine times sine, cosine times 1. All right, so now I've taken care of my multiplying step, so now I can add. So what do you need if you're adding? Common denominator. So I'm going to make the bottom a cosine. And if you multiply the bottom by cosine, you also have to multiply the top by cosine. So what is cosine times cosine? Cosine squared. And I'm writing every single little step here, so some of you can probably skip some of these, but most of them you're going to want to write down. Because you now have common denominators, we can write this as one giant fraction. The denominator is going to stay the same, so cosine will stay the same. And on top, you're going to have cosine squared x plus sine squared. And what is cosine squared plus sine squared? 1. What's 1 over cosine?
Cosecant.
Cosecant. Wait, no. Secant.
Secant. Whatever. SCC.
SEC.
I just don't know what it's called. That one was just long.
Mm-hmm.
Are most problems gonna be that long? Or is that like a,
You mean on the test? Or just in general?
yeah, on the test?
I don't know yet. I haven't made it. You probably will have a couple that are lengthy like that. Not all of them, though.
Okay.
I'll throw in some easy ones, but I might throw in a couple hard ones, too. This guy right here was one of my Valentines. I don't know if you remember when we did the Valentine's math or whatever,
Yeah.
right? And so I think it was tangent C over cosecant C. And so when you simplify all of that down, it simplifies down to, how did it go? I can't remember, but it simplified down to sec C. Right? You get it? I'd have to go look it up to see what the original fraction was. All right, anyways. Now we have our cofunction identities. And so my cofunction identities are going to come from shifting my graph. All right, so let's think about sine and cosine real fast. So the sine graph,
Do we need to write this?
no, just watch me do that, this part, something like this, I don't know. Sine graph goes like this, right? And the cosine graph goes like this. If I were to shift the sine graph over pi over 2, right? So instead of starting at 0, I'm going to shift it over here, pi over 2. Do you see how if you shift it pi over 2, it would make the bowl shape and it would make that cosine graph?
Mm-hmm.
Okay, same thing with the cosine. If you were to shift this over pi over 2, and you would start here, it would make
Sine graph.
the sine graph. So that's what these cofunction identities are talking about. They're saying if I were to shift my functions over pi over 2, you would get the other graph. And the same thing works with secant and cosecant with the u's, right? If you were to shift them over, you would just shift. And same thing with tangent and cotangent. So you can kind of see on my poster was over there, which would be more sense than me trying to draw it. If you were to take cotangent, which is this guy right here, and you were to shift this over, this is at pi, if you were to shift this over pi over 2, your asymptotes would be here, which looks like the tangent, right? And then we do take care of the squiggle with the negative in here, so it's kind of like shifting and a little negative, a negative flip happening. So both of those are taken care of when we're talking about these identities. Because if you think about this one here, that's like a negative sign, right? But so anyways, the negative is taken care of along with the shift. All right, so what you need to know, you don't really need to, that just helps understand why this works. But what you need to know is that if you have the pi over 2 minus pi, right, the pi over 2 is your shift, the minus is your reflecting, that is going to give you the exact same graph as cosine. And if you have cosine of pi minus 2 minus theta, that's going to give you the same graph as sine. Because you're going to shift it, you'll flip it, it'll give you the exact same graph. And that's going to work for all of them. So secant and cosecant. If you have secant of all of that stuff, that's going to give you a cosecant graph. And if you have cosecant of all that stuff, it's going to give you a secant graph. And then, of course, if you have tangent of all of that stuff, that's going to give you a cotangent graph, and cotangent will give you a tangent graph. Because sines and cosines look like waves, cosecants and secants look like the U's, tangents and cotangents are the squiggles. So the way that we can use that is down here. If I tell you that sine theta is -1/2, and I want to find cosine pi over 2 minus theta, I know that cosine of pi over 2 minus theta is the same thing as sine. All right, so that's called a It's called a cofunction identity, and I know that sine theta is going to equal -1/2. All right, so the last one for today. If cosine theta equals 0.38, find sine of theta minus pi over 2. Now, what is wrong with sine theta minus pi over 2?
The theta's on the inside.
Yeah, the theta and the pi over 2, they are flipped. So normally we have pi over 2 first. Does that make sense?
Mhm.
So if I want to unflip them, what do I have to take out?
Negative.
A negative. So I'm going to take sine, I'm going to take a negative out so I can unflip pi over 2 minus theta. And then I'm thinking even and odd, if I have a negative inside the sine, is it going to go away or come out? Is sine even or odd?
It's odd, so it's gonna come out.
Yep, it's odd, so we can pull the negative out. And I know that sine pi over 2 minus theta, that's one of my cofunction identities, which is what I was trying to get it to. So that's the same thing as cosine. And cosine is 0.38.
So it's a negative.
So my final answer is negative 0.38. Kind of make sense?
Yep. That's it.
All right, so let's look at your homework because I did make one mistake. Number 11. I just stopped typing for whatever reason. There should be a plus tangent negative theta after that to simplify it down. So on the last four here, 9 through 12, those are just simplifying like we did yesterday and the day before. So you're just simplifying them down. I'm not a huge fan of number 12, but I want you to give it a go. The only reason why I don't like it is because it doesn't simplify to one trig expression. It will simplify, but it simplifies to a fraction. So I want you to try it because it does have good stuff happening in it. It just doesn't simplify down to one trig expression. So you can check the key and I will do it on Monday if you need me to. All right, but all the other ones will simplify down to like a one trig expression where you kind of feel like, oh, okay, this is it, I'm done. Okay, I want to look at just one of these guys because I want to show you, on some of them, you might have to do stuff to this guy and stuff to this guy. Whoa, what just happened? Okay, here we go. So we kind of already talked about how to rewrite the cotangent with the pi over 2 in the front. Like we just talked about how to do that. But this one is not helpful with the negative inside. So if I were you, I would rewrite the given expression. I would simplify the trig so it doesn't have a negative. So for example, on this one, I know that tangent is odd, so I'm going to pull the negative out. So I can say negative tangent y equals 0.9. And so then I can divide by the negative, and I can say that tangent y is negative 0.9. Does that make sense? Like you kind of have to make that trig normal so we can use that after we use the identity over here.
Mm-hmm. And then we do the thing.
Yeah, and then you do the thing that we did. Take the negative out, it's cotangent even or odd, change it, and then use the given information to evaluate. Okay, does that make sense? It's not too bad. I did the homework this morning. It was a nice homework. You are going to have a homework quiz on Monday over even, odd, and co-function identities. So just be ready for that though.